We are in section 2.3, product and quotient rules and higher order derivatives. So now we're starting to learn some more formulas that we need to have memorized for upcoming exams and quizzes, and then also make sure you have these known as you're working through the homework. More complex functions will need additional tools in order to differentiate them. The first of these that we're going to look at is going to be the product rule. Product again means to multiply. So this says if f and g are differentiable functions, then f times d is also differentiable. And the derivative of f of x times g of x is going to be the first one times the derivative of the second plus the second times the derivative of the first. Or it's written in words as first times derivative of second plus second times derivative of the first. And so note that you cannot, this is a no, don't do this. You can't just distribute that derivative on each of those terms. You would have to do, so if you were to take the derivative of u times v, you're going to have the first times the derivative of the second plus the second times the derivative of the first. And this is the product rule. So the example down below says find the derivative of f of x equals 3x squared plus 1 times x to the fourth minus 3. And so the techniques that we had in the previous section with using the power rule, we had to multiply this out, combine like terms, and then take the derivative. But we're going to go ahead and try to use that product rule. So we have one product, one of those factors in the product is going to be 3x squared minus 1, and the other one's going to be x to the fourth minus 3. So taking the derivative, I'm going to say f prime of x is going to be equal to the first, which is 3x squared minus 1, times the derivative of the second. And the derivative of the second is going to be 4x to the third minus, and the derivative of 3 is just 0, so it's just going to be 4x to the third. Then we have a plus, and then it's going to be the second, which is x to the fourth minus 3 times the derivative of the first. And the derivative of the first is going to be 3x squared, which the derivative of that is going to be 6x. Minus 1, the derivative of that is just 0. So it would just be 6x. From here, I need to simplify this. I can distribute my 4x cubed. Doing that, we're going to arrive at 12 x to the fifth minus 4x to the third, and then distributing my 6x, we get plus 6x to the fifth minus 18x. From here we can combine like terms. We have 12x to the fifth plus 6x to the fifth, which is going to become 18x to the fifth minus 4x cubed minus 18x. And then the problem right next to this we have is going to be find the derivative of f of x equals, and our first factor here is being square root of x minus 3x, and our second one is going to be 1 minus 2x to the third. And so taking the derivative, put f prime of x, and it's the first term, and I'm going to rewrite that, and I'm going to rewrite it up above as x to the 1/2 minus 3x, and then 1 minus 2x to the third. So it's the first one, which is x to the 1/2 minus 3x times the derivative of the second, which the derivative of 1 is a 0, and then minus 6x squared, plus our second one, which is 1 minus 2x cubed, times the derivative of the first. Taking the derivative of our first term, we get 1/2 x to the, and then subtracting 1 from the exponent will be negative 1/2. And then minus 3x, the derivative of 3x is just going to be 3. So from here, I'm going to distribute my negative 6x squared. And so we get negative 6x to the, and from here, we need to add our exponents, and so we're going to have 2 plus 1/2, which you can think of as 4 over 2 plus 1/2, so we get a common denominator. and that's going to become 5 over 2. And then we have negative 6x squared times negative 3x, which is going to become positive 18x to the third. And then for the next part, we need to FOIL this. And so 1 times 1/2 x to the negative 1/2. And then 1 times negative 3 is just negative 3. And then we have negative 2 x to the third times 1/2 x to the negative 1/2, which would be negative x to the, and again, combining these exponents, we are going to have 3 minus 1/2. So same as 6 over 2 minus 1/2, gain that common denominator, which is also going to be 5 over 2. And then the last one that we have is negative 2x cubed times negative 3, which is going to be plus 6x cubed. So from here, we're going to combine our like terms. And we have a 18x cubed and a 6x cubed, which is going to be 24x cubed. And then we have a negative 6x to the 5/2 and a negative 1x to the 5/2. So we have negative 7x to the 5 over 2. Then we have a plus 1/2 x to the negative 1/2 and a constant term of minus 3. From here, I'm just going to rewrite my rational exponents as radicals. And so it's going to be 24x to the third minus 7, and this is going to be the square root of x to the 5th, plus, and then the x to the negative 1/2 will move to the denominator and become a square root, minus 3. And so this is the derivative of that function using the product rule. Again, we could have FOILed this at the very beginning, multiplied it out, and then taken the derivative with those power rules. But this was good practice to get to use the product rule. Right below this, we have our next formula, which is the quotient rule. The quotient rule says if f and g are differentiable functions, then f divided by g is also differentiable for all x such that g does not equal 0. And so for this, we have the derivative of f divided by g is going to be g of x times f prime of x minus f of x times g prime of x all over g of x squared. So for this one, the way I remember this is by using this little saying, and it goes low d high. So we say low d high, which is like the derivative of the top, minus high d low, all over low squared. So what this means is it's low, so we write the bottom function, times the derivative of the top, minus the top times the derivative of the bottom, all over, so that's all the numerator, all over the denominator squared. And so, again, there's a little note here, don't do this. This is incorrect. And so we have an example here that says find dy dx if y equals 2x plus 3 over 5x minus 1. So dy dx is going to be equal to, and it's low, and our low factor is the denominator. So we have 5x minus 1 times the derivative of the top, so d high, which is just 2. The derivative of 2x is 2, and the derivative of 3 is 0. Minus, this time it has a minus. The product rule has a plus. Quotient rule has a subtraction sign or a minus. The top, which is our high, so 2x plus 3, times the derivative of the bottom, d low, and that would just be 5, all over the bottom squared. So you just write the denominator, which was 5x minus 1, and square it. From here, I'm going to distribute my 2 and my 5, so I'm going to end up with 10x minus 2. And then my 5 gets distributed, and then also your negative sign is also going to get distributed. So a couple things to keep track of. So we have minus 10x minus 15 all over 5x minus 1 squared. So your 10x's will reduce and just sum to 0. And so we get negative 17 over 5x minus 1 squared. And so again, anytime you have a quotient, so this is going to be something that you have a numerator and a denominator that are going to be polynomials that you're unable to simplify, you have no workaround and you need to use the quotient rule. So looking at the example right next to this, it says find the derivative. Remember that was another way to write the derivative of, and we have 3x squared minus 5x all over 2x minus 7. So our derivative is going to be equal to, and I'll just put y prime here, the bottom, which is 2x minus 7, times the derivative of the numerator, or the d top, and this is going to become 6x minus 5. So using those power rules, minus the top, which is 3x squared minus 5x, times the derivative of the bottom, which is 2. All over 2x minus 7 squared. So from here we need to FOIL the first part and distribute the 2 and the negative on the second. And so multiplying the first two factors, we get 2x times 6x, or 12x squared, minus 10x minus 42x plus 35, and then minus 6x squared plus 10x all over that denominator, which is 2x minus 7 squared. From here, we're going to simplify what we have and combine our like terms. So we have a 12x squared minus 6x squared, so 6x squared. And then we have a 10x that's negative and a positive one that will cancel out. So we also have a minus 42x. And then we have a constant term, which is plus 35. All over 2x minus 7 squared. We're unable to simplify this anymore, so this would be our final answer. The example on the next page, I'm going to go ahead and circle, and we'll work out this one together in class. Right below this, we have what's called higher derivatives. So sometimes you might not need just a first derivative like we have been doing, but maybe a second derivative, or a third derivative, or a fourth derivative, and this process will continue. We'll see later on the importance of certain higher order derivatives and how they're applicable, especially for the economics part of this class. So the higher derivatives are going to be f, and you'll notice 2 little primes there, and then 3 little primes there, and then after that it gets a little too challenging to write all those little dashes, and so they switch and they'll start putting that as an exponent. So they'll say the fourth derivative, but they put the 4 in parentheses, are defined by taking a derivative of a derivative is exactly what you're doing. So the second derivative here is taking the derivative of the first derivative, the third derivative is taking the derivative of the second derivative, and so on. So the example right below says find the second derivative given our function. But in order to do that, we can't just jump and do the second derivative. We actually have to find that first derivative. And so taking the derivative of f of x, we get negative 6 times 4, which is negative 24x to the third, plus the derivative of x cubed is going to be 3x squared, minus the derivative of 3x squared is going to be 6x, and the derivative of 2 is just 0. So this is our first derivative, and we need to use this to find our second derivative. So taking the derivative of the derivative, We're going to have negative 24 times 3, which is negative 72, x to the second, plus 6x, and then the derivative of negative 6x is going to be just negative 6. And so you can see as you're taking derivatives, those powers are getting smaller as we go. Eventually we would hit 0. The next example says to find the fourth derivative of f of x equals 1 over x. And so in order to get the fourth derivative, we first need to find the first, then the second, then the third, and then we can arrive at the fourth. But I'm going to go ahead and first rewrite this function as x to the negative first. And so our first derivative of this is going to become, using the power rule, negative x to the, and it's always subtracting 1 from the exponent. So negative 1 minus 1 would become negative 2. Our second derivative is going to be negative 1 times negative 2, or positive 2, x to the, and subtracting 1 from the exponent. This is now going to become negative 3. Our third derivative is going to become 2 times negative 3, or negative 6. X to the, subtracting 1 from the exponent, will become negative 4. And then our fourth derivative, taking the derivative of negative 6 x to the negative fourth, we have negative 6 times negative 4, or positive 24. X to the, subtracting 1, negative 5. I'm going to rewrite this as 24 over x to the fifth. So this is my fourth derivative. The next example, I'm going to go ahead and circle, and we'll look at this one together in class.